Good morning. Today we're picking up with Chapter 3, Lesson 1, Day 2. Our objective is to identify proportional and non-proportional linear relationships by finding a constant rate of change. So we started looking for that constant rate of change yesterday, and we are going to continue today, and we're going to throw in the extra idea of being able to tell if a linear relationship is proportional or not. So a linear relationship is proportional when two quantities, for example A and B, have a proportional linear relationship if they have a constant ratio and a constant rate of change. An example in symbols is if we take one of those changes, B over A, and it's constant, the change in B over the change in A is also constant. To determine if two quantities are proportional, compare the ratio B over A for several pairs of points to determine if there is a constant ratio. Now we ran into this yesterday when I went through that last example in the lesson, and when we looked at the relationships, they weren't all the same. They varied. So in that case, the relationship was not proportional. So we'll go through some more examples like that today. Example 2. Use a table to determine if there is a proportional linear relationship between a temperature in degrees Fahrenheit and a temperature in degrees Celsius. Explain your reasoning. So we've got degrees Celsius going up by increments of 5. So we add 5, add 5, add 5 as we go up in degrees Celsius. And then degrees Fahrenheit, we go from 32 to 41, which is adding 9, 41 to 50, adding 9, and so on and so forth. So right now we're consistently adding 5 each increment for degrees Celsius and adding 9 for each increment in degrees Fahrenheit. So when we look for a constant rate of change, we've got the change in Fahrenheit, which is plus 9, over change in Celsius, which is plus 5. Since the rate of change is constant, this is a linear relationship. To determine if the two scales are proportional, express the relationship between the degrees for several columns as a ratio. So we can take 41 over 5. So 41 over 5, we get 8.2. 50 over 10, 50 over 10 is 5. And 59 over 15, 59 over 15 is about 3.9. Since the ratios are not the same, the relationship between degrees Fahrenheit and Celsius is not proportional. So there was a constant rate of change, but they're not proportional because each of these fractions, when we convert degrees Fahrenheit over Celsius, does not give us the same answer. We had 8.25 and 3.9. To check it, we can graph the points on the coordinate plane, then connect them with a line. The points appear to fall in a straight line, so the relationship is linear. So a straight line means they're linear. The line connecting the points does not pass through the origin, so the relationship is not proportional. So basically our graphed line starts at 30 instead of 0, so that tells us that the relationship is not proportional. If our line went through the origin, 0, then it would be proportional. So let's work through the guided practice together to get some more experience with this. Number 1 reads, the amount of paint Y needed to paint a certain amount of chairs X is shown in the table. Is the relationship between the two quantities linear? If so, find the constant rate of change. If not, explain your reasoning. So we're looking at change in Y over change in X. So our change in Y, 6 to 12 is 6, and 12 to 18 is 6. Our change in X, 5 to 10 is 5, 10 to 15 is 5. So we can illustrate that by taking the change in Y over the change in X. The change in Y consistently is 6, and the change in X is consistently 5. So the answer is yes, it's linear. So let's look at example 2. This time we'll be looking at a graph to see if we can determine if this relationship is linear. The altitude y of a certain airplane after a certain number of minutes x is shown in the graph. Is the relationship linear? If so, find the constant rate of change. If not, explain your reasoning. So to work on this problem, first we have to interpret some of the data here. So let's look at our scale. We're going up by 2,000, 2,000, 4,000, 6,000. So 3,000 would be right in the middle, and this first dot would be 3,500. The second, 3,000. And the third would be 2,000. as we travel from 3,500 down to 3,000, we have a change of 2. And as we travel from 3,000 down to 2,000, we have a change of 4. So this stands for 2 minutes and 4 minutes. So to understand this better, we can create a table. And we know that at 0 minutes, our altitude was 3,500. So at 0, we're at 3,500. At the 2-minute mark, our altitude is 3,000. And at the 6-minute mark, our altitude was 2,000. Now I left a gap in my table on purpose, and I'm going to leave an extra slot. So as we have a change of 2 in minutes, we decrease by 500. And as we have a change of 4 minutes, we have a decrease of 1,000. To determine if the relationship is linear, we can look at our change in y over change in x by taking negative 500 over 2. And we get negative 250. And we can also take negative 1,000 over 4. And we also get negative 250. So our answer is yes, it's linear. And what I wanted to show you here was, if we put in one extra data point, we know because of the pattern of the values that 4 would come between 2 and 6, and then 2,500 would come between 2,000 and 3,000. So even though this data point was missing, we could still tell that this was a linear relationship by looking at the change in y, for example, negative 500 over 2, over the change in x, and the change in y, negative 1,000, over the change in x, 4. And in both cases, we got negative 250, and that tells us that the relationship is linear. Now for problem number 3, we're being asked to determine whether a proportional relationship exists between the two quantities shown in exercise 1. So we're going back up to the paint example. We know it's linear. We want to see now if it's proportional. And remember, we can tell if it's proportional by taking our values from the table, for example, 6, and divide it by 5. So we're dividing y by x, divide 12 by 10, and divide 18 by 15. So if we write those fractions down, 6 over 5, 12 over 10, and 18 over 15. So to figure out if this is proportional, I do my dividing. 6 divided by 5 would give me 1 1/5. 12 divided by 10 would be 1 2/10, which is also 1 1/5 when I simplify it. And then 18 over 15, which is 1 3/15, 1 3/15, or 1 1/5 when I simplify as well. So since I get 1 1/5 when I divide my values y by x in my table, that tells me that yes, that is a proportional relationship. So I hope this helped clarify a few things. We're going to continue practicing, and when we pick things up in our next lesson, we'll kind of branch out and spend more time looking at how can we tell if relationships are linear from a graph and a table, and then how can we take the next step and decide if they're proportional.